Hello, welcome everyone. Thank you for taking some time out to talk about automating vulnerability detection in DevOps using Spinnaker. My name is Anthony Baer, and I am a solutions architect with Sonatype, and here to talk about some of those best practices we can incorporate in terms of detecting vulnerabilities within our applications to make sure that we don't have any threats deployed out in the wild that folks can take advantage of. So first, we're going to talk about defining the problem. And it's really a matter of supply and demand. Today, people are releasing applications faster and faster in order to get them in the hands of their users, to allow the users to be able to take advantage of the full, rich feature set that we are always developing. And supply is in short order. Just being able to develop the applications and do it on a timely basis makes the supply part difficult to come by. In fact, if we were to look at how applications are built today, 90% of the code is sourced from external suppliers. This means that folks are going out to public repositories and looking at open source components and bringing them into their applications to be able to leverage the functionality that they afford, rather than having to build the functionality themselves. So this really causes the development team to be in procurement through looking at what sources they're getting those open source components from, what versions they're using within their open source components to be able to ensure that they don't have any vulnerabilities, and so on. So because they're in procurement, they're going to want to source the best components that they possibly can that are free of any kind of defects, such as vulnerabilities or licensing issues. In fact, if we were to take a look at what the history of downloads has been, the open source software downloads have increased year after year. If we look at the chart that's on the right, starting in 2012 and going through 2020, this year, we find that just within the Java ecosystem that there are about 376 billion components that are being downloaded from Maven Central and the public repositories where folks can be able to get those open source components. Also .NET with the NuGet gallery is also on the rise with folks that are downloading these open source components. And Docker, of course. We have our container images that are being pulled from Docker Hub and being built on that. This information comes from the State of Software Supply Chain report that you see down there at the bottom as a reference. So the reason why folks are doing these downloads of these open source software components is they want to leverage the capabilities that those open source software components provide. Instead of having to reinvent the wheel, use an open source software component to be able to have the wheel already built for you. This also helps in terms of speed of delivery, as we were mentioning before, for the supply and demand. By using these open source components, the component is already built, and we're able to package it and be able to deploy it as quickly as possible. So this helps us for that. However, with great power comes great responsibility. This is the Peter Parker principle you may recognize from Spider-Man, that downloading and utilizing these open source software components wields a good amount of power for being able to build an application. However, you have to ensure that those components that you're using don't have security vulnerabilities or license compliance issues included with them. In fact, if we were to take a look at standard components that are being downloaded from the central repository, as we had mentioned before, about 90% of the components are open source components that folks are utilizing. And so 90% of the components they're using in the application are from open source. About 10% of those, or 11% of those open source components are known to have vulnerabilities. And we found over time that the development community will disclose what open source components they believe to be in use within their application, as you see on the chart on the right. As of 2012, the average is about 25 open source components that were identified as part of an application. But if we were to really investigate and look at the application itself, there were really 2021, then in 2012. And as you see, progressing over to 2018, the gap gets wider and wider in terms of disclosing what open source components are there versus which are incorporated. And this is not necessarily uncommon. It's possible that you are, or the folks that are being surveyed, are using particular open source components as direct dependencies within their application. But then those direct dependencies have dependencies that they depend on, otherwise known as transitive dependencies. So it's not only those direct dependencies that are included within the application, but those transient dependencies that are part of the application too, because they get brought in by that direct dependency. And as I had mentioned before, about 11% of those open source software components that people are downloading from the outside world are known to be vulnerable. So have to be careful. So due to having these vulnerabilities within open source components, there have been some malicious code injections that have been taking place as one of the ways that folks are leveraging open source components to be able to breach data and get data from within applications. And so I won't go through all of these, but just as a couple examples, malicious NPM packages have been typo squatted. So meaning that someone has taken over the repository of an NPM package and claimed it as their own and instead injected in some malicious code within it. So it says here that 40 packages were harvested over 2 weeks, collecting credentials used to publish the NPM repository itself. So enabling the ability to put in malicious code for that. You may have also heard about Docker images that have also been compromised, and crypto mining that has taken place out in Docker images. So as you see, the way that folks are hacking and gathering information from applications has become pretty sophisticated now, and we can only expect this to get more sophisticated as we move forward to be able to avoid being detected. So being able to find these malicious code injections and these vulnerabilities quickly within our applications is of utmost importance so that we know to fix them and we know where they exist and we know how we can go about fixing them. So here's some more examples about data breaches that have been a result of, in the orange, we have open source components that were breached. In the blue, we have breaches that were by a network or other than having an open source component that was vulnerable. So you'll see that in this example, Facebook was breached about 50 million records in there. Marriott Hotels, 383 million packages, et cetera. MySpace, you can see them right here for the different types of vulnerabilities that were utilized to be able to hack into the system. Equifax, and the 2017 Struts 2 vulnerability that was leveraged to be able to breach data within Equifax and be able to gather social security numbers, et cetera, is shown here. So it gives you an idea about the magnitude of the issue. And it's not so easy because the developers that are developing the software, being able to utilize these open source components, traditionally within companies, they will outnumber the security folks in the ratio of about 100 developers to one person that's within security. So some of the ways that can be utilized is being able to do such things as automation, being able to incorporate in this scan for these vulnerabilities as part of your Spinnaker project pipeline, or being able to automate the detection of vulnerabilities and license information as you're doing builds, or even doing such things as shifting left within your development environment to look for those vulnerabilities before they even get into your ecosystem. And we'll talk about that a little bit further. So with having so many open source components as part of our modern day applications, how can we protect ourselves against these breaches that we're now seeing? So I have some recommendations on some themes that we can take a look at as we're going through. So here I've put forth the notion to test early and test often. So instead of waiting until the application has been built and then being able to take an inventory of all the different open source components that have been included as part of the application, test early in the process. Take a look at the different components that are being included as part of your application, even before they're built. Within your development process, within your application development process. Establish policies for evaluating the risk associated with the application. For instance, CVSS scores is a way to be able to know if there were any CVEs that were reported against the open source components. Establish policies that say we want to limit the severity of any open source components. We want to limit the severity of the CVE score of any vulnerabilities that are identified as part of an open source component. We want to say no more than a level 5 on a scale of 10 to be included as part of an application. And the way that the CVE scores are evaluated is how much of a risk it is, how able it is to be exploited, to be able to come up with a CVSS score for that vulnerability itself. As part of this, shift the visibility of vulnerabilities left in the development process to catch the vulnerabilities quickly so that you ensure that you don't have any vulnerabilities that are included as part of your application, as I was mentioning before. Utilize automation to evaluate the application for open source components throughout the development process, including development, continuous integration, continuous deployment, and continuous monitoring. As I had mentioned before, security is outnumbered by development on the scale of 100 developers to 1 security person. So you're going to want to utilize automation as much as possible to create an army for yourself to be able to look at these vulnerabilities to cover all of the different applications that you can have within your environment. So now let's take a look at applying some of these principles to a typical software development environment. So here we have a typical software development environment, if you will, where we have our source control. We've got a build server. We're including in a local repository for open source components. We've also got our Spinnaker server for being able to deploy into the cloud. We've got different environments that are set up to be able to deploy to for development, for quality assurance, user acceptance testing, as well as production. And of course, we have the developers that are going to be creating the applications themselves. Traditionally, developers will draw from the open source control repository for being able to develop their code, as indicated by this arrow we see here. At the same time as they draw from source code control, they will draw from a localized repository for open source components. This localized repository gives us the ability to be able to have a way to control those open source components from the outside world. This isn't the only way that developers utilize open source components. It is possible to download these open source components directly from the public repositories. However, it's not recommended because there's no way to be able to vet those open source components as they're coming into the ecosystem. So by having this localized repository, you have the ability to evaluate those components before they get included as part of the application itself. And here's also where we can apply some guidelines and policies for what open source components are included as part of the application. If there isn't an open source component available within the localized repository, what the repository will do is go out to the outside world to be able to request an open source component. And as I had mentioned before, this is also the time that we could apply some policies and rules to those open source components in order to vet them for any kind of vulnerabilities or licenses that we don't want included as part of our application. Then the developer will go ahead and check their code back into source code control. This will kick off a build, otherwise known as continuous integration, from the build server, and also gives us another checkpoint for being able to apply the policies for our open source components to ensure that what we're building is not vulnerable and meets the policies that we've set forth. The build server will also pull from our localized repository to be able to access those open source components that are part of the application. That way it doesn't have to go to the outside world and helps to expedite the build process. Then the build will be pushed back into the repository. We can store such things as binaries within the localized repository to be able to have those on hand and also be able to expedite complex builds. And then, of course, we get to our deployment stage where within our repository and we have that finalized build, it can then be sent over to our deployment server, in this case, Spinnaker, to be able to be deployed within any of the environments that we have running out in the cloud. If it was in the development environment or quality assurance or user acceptance testing or production, we have the ability, of course, with the deployment server to specify which environment that we want to deploy into and deploy accordingly. So in terms of applying the policies, this is what we have available. As I had mentioned, we have our continuous integration that takes place on the build side of the house. And then we also have our continuous deployment that takes place on the deploy side of the house, if you will. So one of the best practices that we can take into account is being able to block any bad components from coming in from the outside world. Again, in the theme of shifting left and not allowing any bad components to even get into our ecosystem, we can take a look at those open source components that are coming in from the outside world and be able to block them before they even get into our ecosystem so that they won't cause any problems with respect to our applications. Our developers, we can also provide early feedback on those open source components that they've selected as part of the application so that we have the ability to be able to see any vulnerabilities that are being included as part of those open source components that we are utilizing within our application. So this is another best practice and in the theme of shifting left that we can incorporate to improve the quality of our applications that we're building, make sure that they're free from any kind of vulnerabilities so that we can ensure that we have quality applications that are being built. Along with the early feedback, we also can afford our developers visibility into the components that they're using through their IDEs so that they have the notion of which components that they can utilize within their application that don't have any vulnerabilities associated, that are free from any kind of license constraints or issues so that they ensure, again, a high quality application being built. Along with the policies that I was mentioning before, we could apply the policies at the build stage to allow us to be able to not promote a build that we find severe vulnerabilities or license issues that don't comply with the policies that we've put forth. So this gives us another checkpoint within our best practices at the build server to be able to take a look at what is included within the application and not promote it if we find that there's high severity vulnerabilities that are included as part of the application. We also have the ability to enforce policy at the deployment level, doing such things as being able to apply an evaluation of the application before it's deployed in terms of a stage that we'd have within the deployment to take a look at the vulnerabilities that are there. Again, in the theme of automation, we can automate it as part of the deployment process to include a stage in there to do the evaluation to be able to understand if there's any bad components in there. And finally, after we have deployed our application out into our environments, we have the ability as a best practice to take a look at those components that have been deployed and determine whether there have been any new vulnerabilities that have arisen since we've deployed into our environments. So another best practice is to take a look at those environments and ensure that those open source components that have been included have not incurred any additional vulnerabilities um, as they have been deployed out into different environments. So those are some of the best practices. And then going forward, what are some of the best practices that we can incorporate as part of our deployment is testing early and testing often. As I'd mentioned before, vulnerabilities come with using open source software. So as we had seen within the slides earlier, about 11% of the open source components that you can get from the outside world will contain vulnerabilities. So it's up to us to ensure that those vulnerabilities are taken care of, that we are remediating those as well as we can within our applications so that we don't have the kinds of breaches that we had seen earlier in the presentation. We're going to want to create policies to evaluate the risk that we have associated with our open source components. So again, as the example of the CVSS score that I was referring to earlier, we don't want to have any CVSS scores of 5 or greater as a first shot of looking at the different vulnerabilities that you have. So creating policies and having those approved throughout the organization so that folks understand what those policies are and look out for them throughout the development process is important. And then using continuous testing to monitor the vulnerabilities throughout development and beyond. As I was showing earlier, testing within the build process, testing within deployment, using testing for developers to be able to understand what open source components they're using, the vulnerabilities that are there. Use continuous testing as an automation method to ensure that you don't have any vulnerabilities included. As part of some ecosystem enhancements that can be incorporated as part of automating vulnerability detection, track those third-party and open source components as they're going through the life cycle. For instance, we have a specific component that the developer has specified as part of the application. Continue to track that open source component to ensure that you don't have any vulnerabilities that have been discovered as a result of it moving either through the development process or even after it's been deployed. Keeping close to that open source component and understanding if any new vulnerabilities have been discovered is paramount. And then have procurement policies. Again, sourcing from the best, highest quality sources that you can get. Using security guidelines that are, and business rules for them that are enforced all the way to the development level so that everybody's on the same team here and wants to ensure that we have quality releases and that they are free from any vulnerabilities or license issues. So enforce them all the way throughout the organization and have people understand that it's important to have these security guidelines there. Standardize on versions of widely used components. So for instance, many times folks will have the same parser and different versions that are used throughout the organization. If you could standardize on specific components and have them whitelisted, if you will, that will help you to not have any vulnerabilities from components that deviate from that list of standardized components. And then encourage a culture where innovation is embraced. So innovation, in this case, being security minded, ensuring that the application doesn't have any vulnerabilities is very important when working with these vulnerabilities and ensuring that those vulnerabilities do not make it all the way into production and can be exploited. So, with that in mind, I would like to thank you for your time once again in learning more about how to automate vulnerability detection in DevOps with Spinnaker. And I encourage you to drop me a line if you have any questions. Again, my name is Anthony Baer. I'm with Sonatype. My email address is abaer@sonatype.com. Thank you very much, and I hope you have a great day.